Hello, and welcome to the CSAIL Alliance podcast series. My name is Steve Lewis. I'm the Assistant Director for Global Strategic Alliances at MIT's Computer Science and Artificial Intelligence Lab, better known as CSAIL. In this podcast series, I will interview principal researchers at CSAIL to discover what they are working on and how it will impact society. Today on our podcast, I will be speaking to Professor Hal Abelson. Hal is a professor of electrical engineering and computer science at MIT and a fellow of the IEEE. He holds an AB degree from Princeton University and a PhD degree in mathematics from MIT. Abelson has been recognized with numerous awards for his significant and sustained contributions to teaching and undergraduate education, including being one of MIT's 6 inaugural McVicker Faculty Fellows. He has won the Bose Award, the Taylor L. Booth Education Award given by the IEEE, and the ACM Carl Karlstrom Outstanding Educator Award, to name a few. Abelson has played key roles in fostering MIT's institutional educational technology initiatives, including MIT's OpenCourseWare and DSpace. He has also served as co-chair of the MIT Council on Educational Technology. He is a leader in the worldwide movement toward openness and democratization of culture and intellectual resources. He is the founding director of Creative Commons, Public Knowledge, and the Free Software Foundation, and a former director of the Center for Democracy and Technology, organizations that are devoted to strengthening the global intellectual commons. Abelson has published several books, including Blown to Bits, and leads the development of MIT's AppInventor, a major focus of the MIT Center for Mobile Learning, both of which we'll talk about in this podcast. Hal, thanks for joining us today.
Oh, you're welcome, Steve.
Can you tell us a little bit about the focus of your research?
Sure. The focus of my research, God, I've been at MIT for, 50 years. It's really about empowering people about computing. And that can be adults, that can be MIT students, that can be little kids. And the whole thing is sort of looking at, gosh, I sort of grew up as computers were first coming out, and they were wonderful, amazing things. And I like to share that sense of power and amazement with like everybody. And that's the focus of my research.
Great. Can you tell our listeners about AppInventor and why you decided to create it and why you consider it revolutionary?
Oh, sure. So AppInventor is an example of that, empowering people. The idea of AppInventor is that anyone should be able to take these very powerful computational tools and create original, meaningful things that have impact. And the amazing thing that's happening right now is that with the way the technology is developing, everyone can do that. Even third grade students should be able to create things that are meaningful to their lives and meaningful to their families, and even in their communities. And it's something that, we should constantly be impressed and amazed by. And it happens at levels. So it happened, in 2005, 2006, 2007, with the first mobile phones. It's happening again as you see AI tools. And it's happening as you see the very powerful kinds of what today is advanced research coming out from CSAIL, but we know that in 3 years will be in the hands of kids.
So can you tell us about some of the novel apps that these kids have created using AppInventor and how popular is the tool?
Sure. Well, AppInventor runs out of a server that we run at CSAIL. It's got, I would say today, about 800,000 users a month, but it's down because of COVID. When school was in session last spring, we got 1 million active users a month. What's an example? Well, so Dharavi is one of the largest slums in India. It's outside of Mumbai. It's got about 1 million people. The average income is about $10,000 a month. And Dharavi is also the home of the Dharavi Code Girls. And this is a group of girls, ages 12 to 16, who go and use AppInventor, our tool AppInventor, to make mobile apps that are of benefit to their community. So one of the things they've made, for example, is an app that allows you to schedule your family's time at the community water distribution plant. So as you hear a 13-year-old girl talk about it, you don't have to fight. You don't have to jostle for places in line. You don't have to go stand there. And after all, I, as the girl in the family, would be the one who'd have to stand there all day. So it makes a difference to me and it makes a difference to my community. But the point is, with the where technology is right now, a 13-year-old girl can make that. And that's partly because the computers are getting more powerful. So, I mean, everybody knows the slogan that, 50 years ago was the first moon landing, and that the cell phone in your pocket has more computational power than all of what NASA applied to the moon landing. Right? We sort of lose that. So that tells you the enormous potential that anybody can get a hold of. So it's partly the hardware is getting better, and partly the programming languages, and partly the infrastructure. How is it that a 12-year-old girl can go make something that schedules, and the schedule's available to everybody in the community? That hasn't been possible for many, many years. And the thing we all have to appreciate is these things that we thought only could be done at advanced computing labs that took enormous resources are now at the level where even kids can use them.
Right. And that's part of the genius of AppInventor, is that it doesn't require someone to know a coding language like Java or JavaScript, right? This is really, this 13-year-old girl had no coding experience prior to using.
Yes, that's right. I mean, AppInventor is a thing called a blocks language, which means rather than typing text, you kind of have these things that look like Tinkertoy blocks, and you kind of put them together. And you all do this in a web browser, and it's all graphic. And then, the hard part is, how do you go from moving those blocks around in a web browser to actually getting a program that runs on the phone?
And, back in the day, I remember object-oriented programming, right? But this is truly object-oriented programming, where you have these objects, these boxes, right? These Lego blocks that you're connecting, and actually have functions behind them that are doing powerful things, like connecting to web servers, or, doing, polling, or whatever they might be doing.
Yeah, that's exactly right. I'll give you an example of the hidden complexity that's around. So a kid can go into AppInventor and make a little app with a button and say something like, when I press this button, show me my address where I am. Okay, so that's a really simple app. You get an app and it's got a button, and you press the button, it shows you your address. But what's going on there? When you press the button, something is telling the phone to connect to GPS, then taking those GPS coordinates and putting them to a geographic server, which then goes and translates that into your address, and then shows that on the phone. So that's enormously sophisticated, complex infrastructure that we've made. But for the kid building that, you say, show me my address. And the whole infrastructure is full of stuff like that. We've made things that have enormous power that can be addressed very, very simply.
And this is all free, and this is all readily available. People can go to the AppInventor website and look at examples from a gallery and start coding within.
You can go to the AppInventor website, and we put anyone can use it. And then there's a gallery that we have, and we're making a new gallery, so you can see lots and lots of examples, and you can use them too. And even, since MIT is a real proponent of open source code, the entire AppInventor implementation is open source. So if you want to go and make your own server and put it up, and some people have, you can do that too.
That's great. I would encourage people to check that out for sure. So speaking of open source, you're the founding director of the Free Software Foundation. One of them.
I forget, 3 or 4 founding directors of Free Software Foundation.
And so, I had worked for an open source company prior to coming to MIT, and I used to have this debate about open source and free software. And I wanted to get sort of what your take is. What does free software mean to you?
So what makes something free software is what we call the 4 freedoms, right? You can take this software and run it for any purpose. You can take this software and study it and modify it to do what you want. You can take this software and redistribute it. And you can take the software and the modifications that you made and redistribute them. So that's a very kind of precise definition of free software.
And I think people get sort of hung up on free, meaning a price, like it's license, right?
Right.
Fee is that, which is sort of a nuance of it all. But why is that more important more than ever? Why is free software more matter now, and why is it more important?
Gosh, because I mean, think about how much of our lives are controlled by software, and think about how you want that powerful infrastructure to be as transparent as possible. I mean, just look at the debates right now over security, right? How do you know that there's not that your phone or your computer or something doesn't have some hidden thing in it that's doing something awful, even in terms of security? I've got a friend who actually has who has a company that does voting applications, and they're going around to people and getting questions about should we use their voting application. He was just telling me yesterday. He said, he was at some county clerk's office in Mississippi trying to get them to use their voting stuff, competitive with another company. And the question was to those people right then is, how do we know that your voting software doesn't have some bad stuff? There's all this stuff happening around Dominion and stories about that. And the county clerk says, well, how do we know that it's okay? And the guy from the first company says, well, you have to trust us, and it's inspected or something. And the other guy, who's an ex-CSAIL student, by the way, said, well, our software is open source. You and anybody can look at it. And in a world where, I mean, software has always been important, but now it's getting really, really critical important and impinging on people's fundamental freedoms. How do we know that it's doing what they claim to be doing? How can we trust it? And the standard way that you trust things is you have lots of eyes be able to see it. And that's really one of the things that's happening in free software. So a piece of it is you can trust it. You understand what it's doing. And the other one is when you put it out, you're empowering everybody. So those four freedoms are just enormously important and becoming more and more and more important. So every time you hear things about, do we trust the software, whether it's vote counting or billing or anything, say to yourself, what would it be like if everybody could actually look at that software?
It's an excellent point. Excellent point. You're also one of the co-authors of a book called Blown to Bits. Can you tell us what inspired you to write it and what the book's all about?
Sure. So Blown to Bits grows out of two courses. One that we started at MIT, which was there's a sort of level of computing course where it's not really about programming. It's about introducing people to what is this information infrastructure? What are the issues? What's it about? What's it doing? And we taught that course at MIT, and then we dumbed it down so we could teach it at Harvard. And then we said, well, that's really good. Now that we've got it at the level of Harvard, maybe we can do it at high school level. And so that's the genesis of this book, Blown to Bits. And what it is really saying what's it called? It's called your life, liberty, and freedom in the information world. And it's about how that whole stuff is being transformed by the fact that it's on the internet and the web. And you can kind of name the things that are there. There's things like surveillance, there are things like privacy, there are things like copyright. And then the nice thing about it, it starts with these little stories that people can relate to, and then goes into, since we're professors, sort of trying to explain a little bit about the infrastructure. So for example, there's a chapter about security and it talks about encryption. And then there's a little thing that I think works really at a high school level of how does encryption work and what's the technology. And the same thing with copyright, and the same thing with censorship, and the same thing with privacy. So I think what's kind of nice that we really didn't expect when we wrote the book, since we wrote the first edition of that book, of course, there's an enormous, enormous interest in teaching about computing. And that enormous interest comes with societal issues. And what's really nice, a lot of schools are giving students readings from that book to understand the juxtaposition of the technology and the societal issues.
And speaking of privacy, I mean, this book was written in 2008, well before social media platforms were
Totally,
ubiquitous,
right.
right? So it was, I think it was revolutionary in that respect. But, what do you believe the future of data privacy is? Is it too late, to erase our digital identity or put the genie back in the bottle, or be,
Right.
permanently deleted?
Well, there's always, it's really hard to, what's the statement? It's hard to make predictions, especially about the future. But I think that that's over. It's too easy to track people. So, for example, you see all the stuff going on in face recognition right now, right? So you see cities and states, and even now national legislation saying control face recognition, as if that's the problem. But I don't need your picture of your face to identify you. We can do it by gait. We can do it by voice. We can do it by location of where you are. I think there was a nice demonstration about, I guess already about 3 years ago, that said, if you could look at a cell phone's location, which you can now, and you could get 3 readings, just 3 pinpoint readings of where people are, where someone is at various times, you can identify them. And so it's kind of over in terms of people not knowing who you are and in terms of privacy. And we need a different way to deal with it. When you talk about data, I think one of the big debates is in controlling data, do we do it in terms of organizations that individuals can trust? Or do we go to the extreme and say everybody controls their own data? Right? So if you look at, there's a new company that's just founded by Tim Berners-Lee and people. Tim Berners-Lee, the creator of the World Wide Web, who is at CSAIL. And his idea is you have some infrastructure that allows people to set up their own authentication instructions for their own individual data. So, good luck to them. They're trying to take off and become a successful company, but that's one extreme. The other one is the mostly legislative initiatives you see that say the places that hold data are under legal restrictions and have to be responsible. And both of those are very, very active. I don't know where it's going to come out, but it really, really is a concern.
And you are involved with the MIT CSAIL and IPRI research initiative called the Future of Data, Trust, and Privacy. So this initiative kind of goes at the heart of the policy side of the house, as well as the technological side of the house. What do you hope will come from this research initiative?
Well, so you mentioned IPRI. So for people who don't know, that's IPRI, the MIT Internet Policy Research Initiative, housed in CSAIL. And the general idea is that you've got a place that's the top technologists in the world, and they ought to have some way of, first of all, communicating with policy leaders, and secondly, looking at possible important policy implications of their research. So in IPRI, we care very, very much about getting policy leaders and technologists together. And it could be kind of fun. I had the challenge of explaining how machine learning works to a bunch of congressmen and congressional staffers. And so it's sort of nice in terms of empowering people. It's nice to empower the policy leaders too, so that they really understand. But there are also some very, very deep technology problems. So one of the things, you talked about data. There's a thing missing from the way the web works that probably was a mistake that we at CSAIL and others made when we put the web together is when data moves on the web, it doesn't bring with it where it came from, what data people call provenance. So you see some data on the web and you don't know where it came from. So there's no way you can check it, no way you can trust it, no way you can track it. So people are now realizing, 30 years later, that this was a real mistake not to put there. And it's having implications now. Because again, I mean, just look at the things going on with, fake news and disinformation and anything else you see on the web. And imagine that when this thing got transferred over the web, you could say, where did this stuff come from? So that's, maybe our fault in how we set up the web protocols. But in any case, it's a big, big problem. And it's a very difficult technology problem right now to say, can you restore that sense of provenance? But that's only one example. Boy, if we could do that, that would be 10 gold stars in terms of looking at the societal impact of what's happened with the web.
But I think it's also important to look at, the way infrastructure is set up, right? Databases are set up, they're not created to delete records easily, or,
Absolutely.
that whole issue of being able to be forgotten, right? When you have GDPR and in California privacy laws, the regulations might be there, but is the technology there to carry out those regulations?
Well, not really. I mean, you can do a little bit. And again, that's sort of a controversial thing. Who can say what should be deleted?
Well, the user, wouldn't you think? The owner of the data, not the.
Well, the person who got convicted for fraud 5 times and someone's doing checking on them, should they be able to say, okay, that's not on the web anymore? It's not obvious.
Mm-hmm.
And then as soon as you say, well, what should the answer be? It's hard enough in terms of policy to say what you want. And then it's even harder in terms of how would you make the technology do that? Because then again, anyone can go, let's take the fraudster example. Let's imagine we said, it's really good for the fraudster to get that information deleted. Well, that stuff got up on the web someplace and somebody copied it and sent it somewhere else, and somebody summarized it and put it in a database somewhere else, and somebody transformed it in something. That's not easy technology if you decide you want to do it.
And do you believe that this initiative is going to sort of hopefully bring some solutions to solve those tough problems?
You mean the data stuff we're doing in IPRI?
Yes.
Well, we sure are trying, but there are lots and lots of issues like that, that impinge on policy. I mean, one of the other ones that we're looking at is how in the encryption world, in the crypto theory world, there, for example, what's called homomorphic encryption, that says you can have data that's encrypted and sent somewhere else, and then you can still do computation on the encrypted form without anyone knowing what the data is. So nothing's easy, but an easier example than that is I get a bunch of places that are providing salary information, right, about everybody who works in a department, which I don't want to let out, but I would like to know the average salary. So that's an example where where there are ways of encrypting things, where if I send the salaries in encrypted form so nobody can look at it, someone can still use that encrypted information to compute the average. So that's a little bit of the kind of theory magic that's going on right now. But
And
the point is, when you realize that and those possibilities, you say, oh gosh, there are new policy options that mostly the policy world is not taking advantage of, that you could actually do that might provide different ways of addressing the very hard problems that we're doing. So that's a little bit of the vision of both the data project, but also of IPRI overall.
In that homomorphic encryption you were referring to, that's SCRAM, right? That is
Right. That's the particular project we're doing is SCRAM.
SCRAM, right? So if people want to find out more about that, they can go to Google SCRAM at MIT, and you'll find out more about the project.
But I think the general idea is technology can provide different options. It's not as if you go and are going to ask the technologist what the policy is. It's that the technologist can provide new options that maybe policy hadn't thought of.
Can you share a little bit about your collaboration with your MIT colleague, Gerald Sussman?
Oh, Jerry, we've been collaborating since forever. Let me think. We've been collaborating since, what do I want to say? 1971, maybe. So we've been, I mean, we were both graduate students, junior faculty at the MIT AI lab. So the MIT AI lab partly became a thing called the MIT Laboratory for Computer Science, which became this thing called MIT CSAIL. So that's the genesis of where that's coming from. And we were both very interested in AI. I was actually doing stuff in pure math. Jerry was doing an AI project having to do with automatically debugging programs. And we kind of were friends and worked together and just kind of did a lot of stuff because we had similar interests. But then what happened is we both took over what became MIT's major introductory computer science course. From about 1982 to 2006. And during that time, anyone at MIT in either electrical engineering or computer science got pretty much their first exposure to computing by taking our course, which is it's sort of amazing to me that we had the opportunity to do that. But Jerry and I developed that course together and taught it jointly for a long time.
So what do you believe is the future of AI?
I don't know what to say. Even harder, even more complicated. AI today is, I don't know quite what to say. I mean, it's full of promise. It's full of hype. And for whatever hype it is, it really, really is transforming things. And it's at the level where, still it's like every year, every 6 months, you see something that says, gosh, I didn't believe that would even be possible. At the same time, not at the cutting research edge, you're seeing more and more let's call standard applications of AI that are having an enormous impact. Partly because the technology is better and the machines are faster, and partly because there are new platforms people being made where, again, someone with no programming background, anything, can start applying AI to real problems. So I don't know quite what to say about the future of AI other than it's been transformative up to now. And so far, there are no signs of it slowing down.
Can you speak a little bit about explainability behind machine learning? I mean, you talked about open source. It's, you can trust it because you could look at the code. Well, with machine learning, it's a little bit more complicated.
Yeah. There's an enormous problem. I just am consulting at Google. Google is enormously concerned about explainability, as are any of the big tech companies and basically any place that's using AI. At the bottom line, if you have something that makes a judgment based on a computer program or an algorithm or something, people are going to want to ask why. Why should I either accept this judgment, and why should I believe what it is, and how can I explain it? And that general idea is now going through everything that AI is doing. Because as you said, Steve, the actual algorithms are very, very hard to explain. They're based on these giant statistical things with lots and lots of data. And even, the top research scientists and the top machine learning theoreticians or everything don't have good ways of explaining this stuff, or maybe no ways of explaining this stuff. Right? Some people, there really is a train of thought that says you can't explain it. In the sense that why would, if machines ever get anywhere near as smart as people, should we expect that you can explain how brains work? And why should it be that these machines are any easier to explain? There really is that train of thought. And at the same time, there's an enormous efforts at saying, how do you do that there? And they go from I can set up dialogue so you can question the machines, to very, very technical things, looking at the details of these neural nets and saying what's happening. And I guess the research world is divided now between lots of people writing papers saying, here's this new method of doing explainability, and people writing other papers saying, oh, that doesn't work. And behind that, there's an enormous force from policy coming to that. So there are things in the European GDPR which say if there is some judgment made by a system that's applied an algorithm, that the ordinary people to whom this has had an impact should be able to understand it. So the European policymakers wrote that. I don't think they have any more of a clue than we do about how to do it. But it's really hard and it's really important. Because again, there's something like, if you're in a society and the society is being transformed by rules that have an impact on you, you should sort of have a right to understand what's going on. There's, in the US, we're calling that the Fifth Amendment. But what does the Fifth Amendment mean in terms of due process and things, when what did it is this giant machine learning algorithm? So it's really hard and really important. And boy, there are lots and lots of people working on that.
Well, hopefully we'll make some progress, and it'll come out of CSAIL as far as furthering the explainability of explainability.
Yeah, I've got a student right now who's writing a thesis saying one of the key methods there doesn't work.
We'll be looking forward to reading it.
Yeah.
Hal, appreciate your time today. Thank you very much for your insight.
It's been a pleasure.
It was great talking to you, and I'm sure our listeners will enjoy this podcast.
Okay, thanks everybody for listening, and thanks, Steve.
Take care.